All right, next step, what we're gonna do, since the model is ready, right? The composite beam design is completed. The wall we initially set up with the link beam, so ready, and we're gonna we are ready to copy it. If you guys want, you could just assign the diaphragm earlier, but it's up to you. So first of all, I'm gonna just select and go to edit and replicate. Since I already, I don't have a story. Okay, I don't have a story data, so I'm gonna add the story data here. So go to modify here, here. So I'm gonna quick edit this, right? So I'm click the quick add the story up to 40 story, right? And then open it. So it's gonna set all the elevation. Since this one show the fits, I'm gonna change to no inches. I'm gonna change to feet and see what is my total elevation. So change to unit and the story data go okay. So my top 40th floor, I have elevation at 600, right? So this is the story data I added. Now I'm gonna copy and all the way up to the 40. So since I have I select the story 1, I select all the second floor to all the way up to the 40s. I'm gonna copy. Right, just want to make sure when you select it, I think somehow ETABS also copy the boundary condition at the top floor. You see the triangular shape? This is boundary condition somehow. So you need to select all the nodes, go assign, join, restrain, put the free, apply. So delete the boundary condition at the top floor. All right, let me just turn up this section property. It's too dark. So turn up this, turn up this. So this is just geometry. 40-story building is ready. I'm gonna save it. So this morning we start with from this state. So what we start with, we select all this and assign diaphragm, right? Select all this, go to assign, join, and here's the diaphragms and D1. So D1 is, you could see this when you click it, has a rigid diaphragm. So this building has a slab thickness more than 4 inches. Typically, we assume that it's just infinitely stiff, so that we assume this work like a rigid body. So we assume a rigid diaphragm. So say OK. So when you assign it, you see the black dot dash line. So that because all the nodes on the same elevation, this diaphragm is tied together. Eventually, they work like a rigid body. Rigid body. So if you select this plate, right click in the geometry or assignment. Wait a minute, it doesn't show here. I think it shows somewhere. Is that slab information? I think slab information show or node. Okay, node might be node. Nodes. Yeah, you see that this node is tied with the diaphragm 1, but it discrete diaphragm, even though same D1, you see that all the nodes at their same elevation, they are all tied together. So if you put it in XZ elevation, you see the diaphragm is only occur at the floor. Should not be the mix and tied over few multiple floor. Diaphragm should be always at the same elevation, right? So we assign the rigid diaphragm. Now we're gonna create the wind load. Next step, we are going to load pattern. I'm gonna delete and show you from the scratch. So here I'm gonna create the wind load, right? And type is wind. Since ETABS has all the code information, we're gonna choose ASC 716 edit, right? So wind load, wind type, ASC 716. Make sure don't include the 1 because this is only for self-weight calculation. Should be under the dead load. you open this. So this is now your wind load, the design parameters. So what I think at this point, we are referring to, we are using New York City building code, which is 2022, and we are looking for the basic wind speed. So if you go to asc7hazardtool.org, let me go back to here as ATC hazard, ASC hazard tool, right? You should be able to find this, and you could type the zip code address, but I'm gonna type the Manhattan, New York, and this is based upon AC7. Okay, 716. Because this is a commercial building, I assume the risk category 2. I need the wind load information. Wind site class doesn't really matter, but I'm gonna try because this is mostly been using for seismic. So I need the wind data. So I click the summary. So here it showed Manhattan reference. I don't know where it's really referencing, but the wind speed gave me the 115 mile per hour, right? You see the various also mean reference index. This is various wind return period. So this is ultimate wind speed, which I think is equivalent to what, 700, right? So go back to here, we type the wind 15. So this ultimate basic wind speed. The Manhattan, we have a two different group, exposure C or D. In this case, maybe we can try exposure D. Ground elevation factor, topographic factor, we're gonna just keep it 1. Gauss factor is something we need to calculate later, but we'll for now just keep it 0.85. So one thing I want to make sure, so this is diaphragm. Once we did assign the diaphragm here, you maybe can click this and ETABS calculate your building width and depth, right? This is a floor plate dimension, extraction, y direction. So ETABS calculate based upon your rigid diaphragm, and ETABS will be able to calculate your building width and depth for the wind calculation. If you don't see any number right here, you should probably run the model one time so that ETABS will recognize or wake and calculate the diaphragm, the width and depth. So I'm going to click this. Just in case AC7-16, I think you see that the wind, we need to consider total 12 cases, which means wind X, wind Y, and wind X with eccentric, 15% eccentric, right? Wind Y eccentric, both X and Y, or with eccentricity, combination of X and Y. It's all 360 degrees wind effect should be considered for you when you design the building, right? So this, if you keep it, create all section, ETABS will consider all 12 cases. So we set it up the load case. So I want to make sure if you create for the first time load cases, I think ETABS will automatically calculate the load cases. Now let's see. So you see that wind load here. So this wind cases should include your wind load, wind pattern, right? So this is another layer of load cases. But for the first time you create it, automatically ETABS create the load cases and type the 1 load factor here, scale factor. So sometimes you maybe adjust here instead of adjusting at the load combination. So this model is ready for run. So I'm gonna run the model. Oh, okay. So as I said, this building, the proportioning, right? I think because of this cantilever 600 feet tall, we need to check for strength and also stiffness. So what today we discuss is the stiffness check, and then and create the load, the diagram, deflection diagram. All right, so here. So in order to check the deflection, I mentioned I talk about we're going to use a service wind load, right? So service wind load is typically W6 wind ultimate, which is your current wind load. We're going to use a 0.6 factor so that ultimate wind load wind ultimate, which is 115 mile per hour, which basic wind speed is ultimate wind speed. We need to scale down to service level so that I'm using 0.6 load factor. So now with that loads 0.6 wind, I'm gonna check the deflections. Go to display, story plot, right? I'm gonna choose here 0.6 wind. Because this one include a total 12 cases, you'll see both maximum wind deflection in X direction and Y direction, right? So now I know this ETABS give you the old graphic, but since we're gonna running a couple of the model to catch the building to meet the building deflection criteria, the first thing I want to change to inches. Okay, I change the unit, go to display again, spot, and change to 0.6. So I see that here is about almost 19.38, right? And minus X plus and minus. So, okay, with this is my first reference, the model. But I think what I did again, yeah, even this building, that the bottom floor, the wall thickness, what I used 24. Did I use 24 inches? That means this building still needs, right, 24, even C9 go all the way up. This has an issue. So maybe, okay, I'll explain that because so even this current building with the 24-inch thick and concrete strength 9 is not enough. So we may have to do a few exercise. So first of all, I'm gonna collect this data, open the Excel spreadsheet, which we did it this morning here. I'm gonna explain one more time here. Right? So I dump this. Since I'm gonna create the chart, I'm gonna set it up floor information, right? And this is dx, dy, right? This is elevation, but it is inches. So, and this is deflection x and y, right? X and y. So now I'm gonna create the table. I'm gonna use a scatter. Right click, select the data, add, X direction, I'm gonna use this. Deflection, y-axis, I'm gonna use stories, floor information, and I'm gonna call it this first model and dx, deflection in x. I'm gonna do the M2 and no, this M1, but this is dy, extraction, no, this is y, deflection y, and story information. So this morning I show you, this is something I want you to also learn how to use Excel, and title, chart type, legends, okay, which is good, right? So this one is 0.6 wind deflection. This one is floor. This one is deflection, right? Maximum deflection, inches, right? So this is first set. But also I mentioned it, if we set up HO 500 here, since this inches right there, I'm gonna create another column representing our allowable deflection at each floor. So I'm gonna add this allowable h over 500 column, right? Extraction and y-axis. So the current model, we have some issue in y direction, right? So this is model 1. I think that maybe make it a little bigger. So we need to kind of iterate and few more so that we need to increase the lateral stiffness. So I'm gonna stop this at the first, and then we're gonna move on to second round.